Okay, let's look at this question. Look at here, 1 meter, 1 meter, 1 meter, 1 meter, and there is the hinge A and the hinge E. Look at this hinge E. Hinge A is on top of hinge E by 1.2 meter. Point B, and there is a distance B, and they are all 1 meter apart, A, B, C, D, E. And this is like a cable, two hinges. B has a force, 1.8 kilonewton, 3.6 kilonewton, 1.2 kilonewton, and then you can see the distance B, distance C, distance D. Cable A, B, C, D, E support the three loads shown, knowing that DC, he gave you DC only. He gave you this DC, 1.8 meters. He won the reaction at E, this reaction here, and he won the distance dB and dd. Okay, let's look at the question. Let's strip the reaction from the hinges and see. Reaction E, it's EX, EY. Again, the direction of these forces is up to you. You could assume this is positive and this is positive if the value is negative, which means it's in the opposite direction. E. And point D, which is 1.2 kilonewton, distance D. Point C, 3.6 kilonewton, distance C. Point B, 1.8 kilonewton, distance B. Now, reaction at A, AX, and AY. Remember, AY I assume it positive and AX negative, whatever. What's given is DC 1.8 meter. So how could we deal with this? The best is to take moment at A. Or you take moment at E. Let's take moment at A and make a nail here and see that this force will pull the whole entire cable clockwise. 1.8 negative times 1. 1.8 negative, look at the negative, times 1. 3.6 will push clockwise, 2 meter, negative, minus 3.6 times 2. 1.2 will push also negative, minus 1.2, and times 3, 1, 1, 1, times 3. And now, remember, AX is not like the previous example, it was in the line of the action of A, it's shwaya below at 1.2 meter. So, now, let's do the AX. Remember, what is the perpendicular distance between A and X? It's this. This is the perpendicular distance, 1.2. And this will go toward the distance. Okay, so AX will go counterclockwise. So it's a plus. AX times 1.2. AX times 1.2. And this one, AY, also, this is the perpendicular distance. It's going to go also clockwise. Counterclockwise, sorry. Counterclockwise. 1, 2, 3, 4. AY times 4. It's plus. So we put them all. You'll find that now we have two unknowns. 1.2 AX for AY equal 12.6. And we have one equation. Let's do another equation. Let's consider, now remember, we'll keep this equation in mind. Okay, we'll keep this equation in mind. Now, let's take cable EDC. It's up to you, of course, EDC. You just take them only together like this. So, E, it's AX, EX, EY, and D, it's 1.2 kilonewton, and C is 3.6 kilonewton. That's it. Nothing else. Only cable ADC, EDC. So this is the cables. Let's find moment at point C. Find moment at point C. Moment at point C will let this go. Of course, this force will go because this force is in the line of the action of the moment. So this 3.6 will go. It will not count in the equation. 1.2 will go clockwise. 1.2 times the distance. Remember the distance between D and C? Between D and C, it's 1 meter, the perpendicular distance. So, minus 1.2 times 1. And look at this. AY will push counterclockwise, and this is the perpendicular distance. It's 2 meter. Look at the graph, it's 2 meter. So, minus AY. I know. Plus AY because it's going to go counterclockwise. AY times 2. AY times 2. And then AX, now look at AX. AX, and this is the force, and this is the perpendicular distance. So it's going to go clockwise. So this is going to be negative. So minus AX. Now, what is the distance between this from here and here? Let's look at this. The distance from here, from here to here. Because summation of moment at point C, we have to account for this distance, this perpendicular distance, okay, until this point. Okay, so the way we do it here is by accounting what is the total distance. Look at that. The total distance is DC. Look, the whole thing here, it is DC. So DC minus 1.2 is equal to this. And DC was given in the question. Remember, DC was given the question? DC is 1.8. So 1.8 minus 1.2 is equal this distance. So it's 1.8 minus 1.2. And remember, the AX was also negative. Now here we have AY, EX. This is another equation. And we have this equation, the 1. So now we have two equations, two unknowns. We could take this as a function of EX and put it here, so you could find out EY. Well, by rearranging these two equations, two unknowns, you'll get EX is equal to 4.25 kilonewton, and you could find also EY. Okay? So by rearranging, you could find EY 1.875. And of course, we could find the reaction at E, EX squared plus EY squared, all under the square root. So E is equal to 4.65 kilonewton. And we could find the angle. Tan theta is equal to EY over EX. This is by default. EY was 1.875 and EX was 4.25. So theta is tan inverse of 0.441. So theta is 23.8. So the reaction at E is 4.65 and the angle is 23.8. Okay, so now we found the reaction at E. Let's take another free body diagram. Let's take EDCB. EDCB. Okay, and stop. Because we want to find out now, we want to find DD and we want to find DB. Remember what was given in the question? He wants to find the reaction at E. We just found it. And he wants to find DB and DD. So he wants to find DB, the distance DB, and he wants to find the distance DD. So let's take the whole thing from here all the way to B. So we'll do it like this. Remember, we have EX and we have EY, and D is 1.2 and C is 3.6. And this is wrong. It's not going up. It's going down. And that's it. Nothing is here. Okay? So we found a free body diagram. From this, we could find moment at B. Moment at B, everything else will be cancelled. This is cancelled because it's in the line of the action. 3.6 minus, because it's going clockwise, times 1. Minus 3.6 times 1. And then 1.2, this one, minus 1.2 is going minus 1.2 times 2. And then 1.875, this one, it's going to go counterclockwise, times 3, 1, 2, 3, plus 1.875 times 3. And then 4.25, Now, why I took it like that? Because 4.25, you have to account for this distance from E to B. Now, the whole thing is equal to, the whole thing is 1.2 here. So you want to find out the distance from here to this point. The whole thing is 1.2. And what is the whole thing here? So it's 1.2 minus, the whole thing is 1.2, and this is dB. So the whole thing is 1.2 minus dB. You could find this distance. So this distance by 1.2 minus dB. So 1.2 minus dB, you could rearrange the equation, you could find dB, 1.112 meters. So now we found this. So we'll do the last one, which is the DE cable by itself. So 4.25. Only a small portion of the cable DE, and D is 1.2. And let's not take this is wrong. Let's take moment at D. This will cancel out. Now, why I'm taking this, I'll show you right now why. Summation moment at D, 1.875 gonna be plus times 1. And this one, now, this is, we need to find out the angle, the distance from here to here. Okay, let's look at this. The angle, the whole thing is DD, to point D. So this is here. So DD minus 1.2 is equal this distance from E to D. Remember, it's like this. So the distance, this one, is equal DD, the whole thing, minus 1.2. Okay, so 1.2 minus DD, DD minus 1.2 here, you'll end up with DD is equal to 1.641. This is very simple. If you just keep practicing this, you will be fine. Thank you.